In this video, I'm going to walk through each step of Lab 1 and show how you can start building queries in the Watson Discovery Service. Once you're logged into the IBM Cloud, you can search through the catalog to find Watson Discovery. You can then create an instance of Watson Discovery using the Lite plan, which is free of cost. Once the service is created, you can find it in your IBM Cloud dashboard and select the Discovery service. From here, you can click Launch Tool to open up the tooling for Discovery. In this lab, we're going to be using the Watson Discovery News dataset of news articles, which is provided out of the box with Watson Discovery. These news articles have been enriched with Watson's natural language processing technology, and you can see some of the insights gained already if you scroll down. You can see the top concepts and keywords in the news right now, as well as sentiment of articles. In the data schema page, we can see all of the different data fields in our articles, as well as some common values for these different fields. For example, we can see that the articles contain metadata describing what concepts are found in the text, as well as some example values of what you might find in an article. If we switch to the document view, we can see individual documents found within this dataset. In this case, this is just a list of several news articles, and for each one you can see some of the metadata involved. In this article, you can see specific entities that were extracted from the text, as well as the sentiment of the article itself, and more. Now let's query this dataset of news articles. We can start with a simple filter query. Here, let's look for any article that has an entity with the title IBM. You can view a summary of the articles returned here, or in the JSON tab, you can see the actual data payload returned by the API. Now let's try a numeric query. We can search for any document with an overall sentiment greater than 0 or neutral. Now let's do a full text query, which will return documents that have as many matches with the terms provided as possible. Let's also combine that with a search for a specific concept as well. We're going to do a full text search for machine learning and also find articles that have the concept artificial intelligence in them. Within Discovery, you can also choose which fields get returned in your JSON response. So if you click More Options, you can decide to specify specific fields only that get returned. Here we're only going to return the title of the article. And as we can see, the JSON response only contains the title and none of the other metadata for the articles. Discovery can also be used to aggregate data and find insights across the dataset as a whole. This can be done with aggregation queries. Let's write an aggregation query to just find the most common keywords across the dataset of news articles. We can now try performing an aggregation across the set of documents we found in the query from before. Here we'll find the most common entities found in the set of articles that contains the term machine learning and the concept artificial intelligence. Now let's make a nested aggregation. With a nested aggregation, you can look at, in this case, every entity that's involved in your set of documents and only look at the ones that are companies and then try to find the most common companies mentioned in those documents. Another type of aggregation, the numeric aggregation, can do things like find the minimum, maximum, or average of a numeric field within your dataset. Here we're going to find the average sentiment within a specific set of articles. A time slice aggregation can be used to view how your data is changing over time. So instead of just looking at the overall average sentiment, here we can look at the average sentiment every day over a certain period of time. And you can use anomaly detection with a time slice aggregation in order to use Watson's cognitive algorithms to try to see if any data point stands out significantly over during that time period.